Have you ever stopped to think about what connects the battery in your phone, the sizzling pan you're cooking with, and the very DNA that makes you, well, you? It's not magic, but it kinda is. It's this invisible engine that runs our entire world. And today, we're gonna pull back the curtain and look at the fundamental rules of how everything connects.
Seriously, think about that for a second. A battery, a hot stove, the blueprint for life itself. I mean, they seem completely unrelated, right? But there is a single, fundamental force that links them all. It's a force so basic, yet so incredibly powerful, that it drives pretty much everything we see and experience. So what on earth is it?
Well, the answer isn't some complex, far-out theory that you need a PhD to understand. Nope. It's happening right now, all around you and inside of you. It's the constant dynamic dance of atoms.
That's right. The hidden engine of everything is just this: atoms connecting, breaking apart, and rearranging. I want you to imagine a massive, endless dance floor where atoms are constantly looking for new partners, swapping, and forming new groups. These little interactions are what create all change in the universe, from a nail rusting to a tree growing.
Okay, so why do they do it? Why are atoms so social? It's not random at all. This entire dance is driven by one single, incredibly powerful motivation: the quest for stability. And that brings us to the core concept, the chemical bond. You can think of it as atomic superglue that holds everything together. And the secret ingredient in this glue? It's all about the atom's electrons, specifically the ones buzzing around on the outermost edge.
See, an atom with an incomplete outer shell of electrons is kind of like an unfinished puzzle. It's unstable, it's reactive. To find that stability, that Zen-like state, it needs to fill that shell. And the only way it can do that is by interacting with other atoms. So really, all of chemistry is just atoms trying to complete themselves.
And they've got three main ways of doing this, three primary types of handshakes they can make. Let's dive into the rules of connection.
First up, we have the ionic bond. This is the give and take relationship of the atomic world. One atom completely transfers an electron over to another one. We're not talking about sharing here. This is a full-on permanent donation.
So here's how it works. You've got one atom, let's call it the giver, with a spare electron it doesn't really need. It gives that electron away and becomes positively charged. Then you've got the taker, which gladly accepts that electron to complete its own shell, becoming negatively charged. And since opposites attract, bam, they stick together like tiny little magnets.
And this isn't just happening in your salt shaker. Those electrolytes in your sports drink that hydrate you after a workout, they're ionic compounds. It's their charges that allow electrical signals to fire between your nerve and muscle cells. So yeah, ionic bonds are literally what's helping you move right now.
All right, next up is the covalent bond. Now, if ionic bonds are a donation, covalent bonds are a partnership. In this case, two atoms both need electrons to be stable, so they come to an agreement to share a pair, which lets them both complete their outer shells at the very same time.
And this type of sharing? It's the absolute backbone of life itself. Covalent bonds are what hold together the incredibly complex molecules that make you, you. From the DNA that stores your genetic code to the proteins that build your tissues. They are the strong, shared connections that create all biological structures.
And finally, we get to the really unique case of metallic bonds. This is a totally communal arrangement. In a piece of metal, the outer electrons aren't really tied to any single atom. Instead, they just detach and form this free-flowing sea of electrons that moves among a whole grid of positive metal ions.
This unique structure is the direct reason for a property we use every single day: conductivity. You see, electricity is just the flow of electrons. That mobile sea of electrons in a copper wire is basically a perfect superhighway for an electrical current, allowing it to move super easily from a power source to your phone, powering our world.
Okay, so we've got the bonds, these connections that hold things together. But the world isn't static, right? Things change. So what happens when these connections break and new ones form? Well, that's where the real action is. That is a chemical reaction.
And it's actually a pretty simple three-step recipe. First, you start with your ingredients. We call those the reactants. Then, a little energy comes in to break their existing bonds, the atoms shuffle around, and then they form brand new bonds, creating entirely new substances, the products.
And this is a fundamental rule of the universe. It's called the law of conservation of mass. You always end with the exact same atoms you started with. They're just partnered up differently now. You can think of it as the ultimate cosmic recycling program.
So why does any of this microscopic detail really matter to you and me?
Because this constant atomic rearrangement is the engine behind countless things we see, touch, and do every single day. Let's connect it all back to where we started.
The smell of toast in the morning? That's a chemical reaction. The rust forming on an old bike? Yep, reaction. Your own body digesting food for energy? We're talking millions of reactions happening right now as we speak. From batteries holding a charge to plants making the very oxygen we breathe. It's all just atoms breaking old bonds and forming new ones.
So next time you look around, just remember, you're not seeing a world of static objects. You're watching the results of an endless, invisible atomic dance. And it makes you wonder, if atoms suddenly decided to be antisocial and just stop forming these bonds, what would be left? What would existence even look like? It's a wild thought, and it really puts into perspective how these tiny, invisible connections literally build everything.